All right, welcome here. Day number 3, chapter 6. We are going to talk about compound inequalities today. When we think about a compound inequality would be those inequalities that are separated by two or joined by two inequality signs. When we put two inequality signs in there, we start including some words like situations that would be like and or. And again, we'll talk about how to read those as we talk about the examples below. But a compound inequality is important to recognize that they are joined by two separate inequalities. So first here we need to talk about what happens when we have the word and. Well, when we see the word and, we're going to be graphing what we talk about as the intersection of the solutions for each inequality. When we talk about or, we're going to be graphing what is called the union of, or maybe easier to think about that for you guys would be both of the solutions. So when we talk about the word or, the or means that we're going to graph what we mathematically think of as the union of each of those inequality solutions. Or what you guys may want to consider is that this is just graphing both. So when I look down here at number 1, I'm going to graph these in two different colors, but the solutions are going to come, since this is an and, they are going to be coming from, notice up here it says the intersection of these solutions. So again, I need to recognize where 0 is, and I'm going to graph -1 here, 1, 2, 3 out here. If I want to graph x is greater than -1, I'm going to have an open circle, and I want those that are bigger. I'm going to just do this as a line for right now, so like an arrow showing that I like those things that are larger, because when I graph the second inequality here, I get x is less than 2. I'm going to have an open circle at 2. I'm going to graph all those things that are smaller than 2. But the question is, where does the intersection occur here if we were to graph the solutions that are going to satisfy both of these? So what we're saying here is that we want numbers that are both bigger than -1, and at the same time we want numbers that are less than 2. Well, those numbers that are bigger than -1 and less than -2 are these numbers that are in between -1 and 2. And again, notice this is where the intersection is with the blue and the red. Again, examples of numbers that would satisfy this would be something like, say, 1. We know 1 checks over here. 1 is bigger than -1. We also know that 1 is smaller than 2. When I look at problem number 2 is an or statement. So again, I'm going to put 0 on my number line. I'm going to put some numbers here, and I would like to graph the or statements. So in an or, I'm going to first graph x is less than or equal to 0. So here's 0. This is the or equal to, so it's closed. I would like to graph all those numbers over here that are smaller than 0. I'm going to also graph on the same number line the numbers that say x is greater than 2. So here is 2. I'm going to graph all the numbers that are over here. And it's important that we understand in the English language what the word or means. It means that solutions can occur either from the red shaded area or from the blue area. So if you think about that, you're asked to go to the store and you're asked to get a piece of fruit, and maybe you're asked to get a banana or an apple. Well, maybe over here would be all the examples of getting a banana, and over here would be all the possibilities of getting an apple. So here's banana to the left, here's an apple to the right. Well, it doesn't matter if you get any of these or one of these, that would satisfy being a solution. So if we went through and checked some possibilities, if you tried something like -3, -3 is right here. -3 satisfies being smaller than 0. Though it's not bigger than 2, I only need to satisfy one of the cases. So it satisfies here because an or would mean it either needs to be this or this. It's not and would require you to get both. If you think about that, like that banana example, if you went to the store and were asked to get a banana and an apple, well, you're going to have to come back with 2 items, or something that satisfies both for both of them, which is why that's the intersection. All right, problem number 3 here. It's going to ask us to write and graph the compound inequality for the following. And it says all the real numbers less than or equal to 3 and greater than 0. So if I say all the real numbers less than or equal to 3, I'm going to get x here is less than or equal to 3. I can also write the word and say and all the real numbers that are greater. So now this is x is greater than 0. And again, if you would like, you could write it like this. Oftentimes when we see the word and, we can recognize here that we can put our variable in the middle, put the smaller number on the left, the larger number on the right, and we can say that x then would have to be a number that is between 0 and 3. We need x to be greater than 0. So if you read this from right to left, x is greater than 0. That's the same as what this says. We just switch which side the x is on, and since we switch the side of x, we flip the inequality side. And then we can say here that x is also less than or equal to 3, which is again this inequality sign. Again, I'm going to put the word or, because really which of these you put is up to you. You would not need to have both of these. You could write the top one, you can write the bottom one. When we graph them, remember that we are graphing the intersections of these, so I'm going to graph the top one. So the top one here, if I graph x is less than or equal to 3, I'm closed at 3. And we're going to be going to the left. I also have here, I'll do it in a different color. X is greater than 0, so I'm open at 0. And graphing all those numbers that are greater than that. And then I would like to shade my solutions, which are the intersection, which is all the numbers in between 0 and 3. Remember, an and statement is the intersection. If I match it up here, here is x located in the middle. If x is located in the middle, we are graphing the numbers between 0 and 3, open at 0, closed at 3. When I slide down to example 4, we are going to graph all the real numbers less than 2. And then we have the important word here. We're going to highlight this in red. Or we need those numbers that are greater than 4. Again, we're going to need to write this as two inequalities because it is an or statement. And we cannot write it where x is between, like we did up here on the one above. So as I write this here, I'm going to get x is less than 2. And then I'm going to use that word or. We say all real numbers x that are greater than 4. Here is what I'm going to need to come back and graph. So again, I'm going to set up my number line. Here's 0, 1, 2, 3, 4, 5, 6. If you'd like, we could throw the negatives over here. We're going to first graph x is less than 2. That's open at 2, and all the numbers less than it are all the numbers to the left. If we take a look at x is greater than 4, x is greater than 4, open at 4, and all the numbers here greater than 4 are bigger. Then 4 continues on past 6, goes on forever. And again, an OR state would mean that we could pick solutions from either this portion over here, and a number over here in the blue shaded region, or even further over here would be satisfy this inequality, or we could pick something that is over here. Again, remember, an OR is graphing both solutions, and is graphing the intersection. When I go to problem number 5 here, directions are going to ask me to solve and graph the inequality. So what I need to recognize here is now not only do we have one inequality, we have what is called a compound inequality. And in this compound inequality, we need to solve for x, where x is located in the middle. What I want to do though here is remind you guys that we keep this idea of balancing an equation, or in this case, balancing inequality, uh, you know, those rules continue to apply. So if I add 3 to the middle, I need to add it to the right. I also need to add it to the left, because what we do in an inequality is we need to keep it all balanced. Here, it's not just to the left and the right. Here, it's to the left, a middle, and a right. So as I do this, I get -1 plus 3 is 2. We get x by itself here, and 4 plus 3 is 7. This is my inequality. This is read as 2 is less than or equal to x, and x is less than 7. If I would like to graph this, what I need to do is I need to recognize where 0 is. And I need to graph the numbers. In this case, I'm going to remind you that this is an AND statement. And we'd like to graph the intersection of this, or I want to graph all these numbers that are between 2 and 7. So I'm going to go closed at 2 because it was or equal to. I'm going to go open at 7 because it's less than 7. And I'm going to just be shading these numbers that are between 2 and 7. As we prepare for problem number 6. I'm going to keep myself organized here. I'm going to put my left, my middle, and my right boundaries. And again, we're going to work to solve. When I work to solve here, to get rid of a positive 4, I'm going to subtract 4 in the middle, on the left, and on the right. As I do so, I get -4 is less than or equal to -2x, which is less than or equal to 6. I'm going to divide by -2. Remember, if we multiply or divide by a negative number, we have to flip. So as I bring this down, I'm going to put this word here and say we are flipping these inequality signs because we divided by a negative number. So I'm going to flip both of them. I'm going to do them in purple to make it a little bit more obvious. And then we need to understand -4 divided by -2 is +2. 6 divided by -2 is -3. This is read as 2 is greater than or equal to x, and x is greater than or equal to -3. Well, you can graph this the way it is, because what we recognize here is that x is going to be between. This is also an AND statement. So I'm going to set up some numbers on my number line. I'm going to go closed at 2. I'm going to go closed at -3. And I'm going to be graphing all these numbers that are in between -3 and 2. Please note that this is equivalent. So I'm going to say, maybe I'll use the word also written as, if I put x here, small number of -3 on the right, large number of 2 on the, small number of -3 on the left, large number of 2 on the right. If I read this from right to left, we have -3. Again, when I said reading it from the right, -3 is less than or equal to x, and x is less than or equal to 2. So I can write this like that. And this would be also able to be written like this. And those are equivalent expressions or inequalities. They're just a matter of whether or not we are putting the small number on the left or the large number on the left, being that 2 or that -3. As I slide down to problem number 7, here is an OR. When I have an OR, remember we are going to graph both of the inequalities. Well, if I'm going to graph both the inequalities, I need to solve both the inequalities. So in this first one over here, we're going to add 6 to both sides. And we're going to get negative 4 is greater than or equal to x. And then we have or. I'm going to need to solve this one. So I'm going to work to put my x's on the same side. So I'm going to subtract 2x. 6x minus 2x is 4x. Subtracting 5 is greater than 3. I'm going to add 5 over to isolate my 4x. I'm going to divide by 4. And we get here x is greater than 2. And again, like I had listed above, we are going to need to graph both these solutions. So I'm going to set up my number line here. I'm going to graph the red one first. This says negative 4 is greater than or equal to x. Here's negative 4. If negative 4 is the larger of those, then the values that satisfy this are those that are to the left. The numbers that are smaller are those that are more negative, right? As we take a look at the blue one, here's the other one. This is going to say x is greater than 2. We're an open circle at 2, and we're going to shade to the right. Our solutions to this inequality or to this compound inequality can either come from the stuff that's over here in the red shaded area or this area in the blue. And again, next up here is day 3 homework. Welcome to the introduction here to compound inequalities, and best of luck.